Hello students, let's solve the next numerical. The cable AB carries a tension of 400 Newton. Determine the moment about point O of this tension as applied to point A of the slender bar. Now, we have been told that the cable AB carries a tension. Tension always acts away from the joint. We are talking about joint A. Therefore, the tension of 400 Newton will act away from joint A. Now we have to calculate the moment about point O. We have not been given the angle at which the 400 Newton is acting. Therefore, to calculate the angle, we will first resolve the force, but since we do not know the angle, we will keep the forces as pending. So we will have one force in this direction and the other force in this direction, since the 400 Newton force is going in the second quadrant. Here, to calculate this angle, we can clearly see that we need this right angle triangle. For this right angle triangle, we need to know this dimension, that is the opposite, and we need to know this dimension, which is the base or the adjacent. To calculate this, what we have been given is a 500 mm distance OA and the angle 30 degrees. So what we can do is, we can consider this right angle triangle in which we've got an angle and we've got the hypotenuse. So what we can do is, we can use sine theta, that is opposite upon hypotenuse, to calculate the angle. With this, to calculate the opposite distance, that is this distance. Since hypotenuse is given, that means 500, theta is given as 30 degrees. That's how we calculate the value of opposite, which comes out to be 250 mm. Converted into meters, it becomes 0.25 meters. Also, we can use cos theta, that is adjacent upon hypotenuse. And using this particular equation, we can calculate the value of the adjacent, which comes out to be 433 mm. That is nothing but 0.433 meters. Now, since we have already calculated the distances, that is this distance comes out to be 0.433 meters. And this distance opposite comes out to be 0.25 meters. Now, using this, we can calculate the remaining distance over here. That means 650 mm or 0.65 meters minus 0.25. This leaves us with 0.4 meters here and 0.433 meters as is down. We take the same distance over here. Now, calculating the angle, we simply take the value of tan theta as opposite. So for this angle, 0.4 will be opposite and 0.433 will be adjacent. That's how we get the angle theta as 42.73 degrees. Now that we have calculated the angle, let's go ahead and calculate the moment. So now we have moment about point O. Since we have already made the different directions, let us name the forces. So this will be 400 sine 42.73 and this will be 400 cos 42.73, since this angle is 42.73. Now we have to simply apply the equation of moment. Moment is force into the perpendicular distance. That means if your force is vertical, we have to find a distance which is horizontal between the point of rotation and the line of action of the force. Similarly, if your force is horizontal, we need a perpendicular distance, so we need a vertical distance between the point of rotation and the line of action of the force. Therefore, let's consider the 400 sine 42.73 force, which is vertical. Therefore, we need a horizontal distance which comes out to be 0.433, and this takes us into an anti-clockwise motion. Therefore, we term it as positive. the other force, that is 400 cos 42.73 force into the vertical distance, so that is 0.25. This again goes into an anticlockwise motion, therefore it is positive. That's how we can calculate the motion, the moment about point O, which comes out to be 190.98 Newton meter. Since it is positive, we know that this is an anticlockwise moment.